Okay, here we are with the Lafayette Telsat SSB-140. This one has had a rebuilt VCO block installed. Had a new varactor diode and electrolytic capacitor installed in it. Had a lot of work done in this area. This one actually let me show you everything's been replaced in this one first. Here's all the tantalum capacitors, all the aluminum electrolytics that have been replaced. Someone had, amongst their screwing up all the circuitry in here, they had for some reason run a wire from the meter, from the modulation and signal, also the received signal meter, had run that back to a hotline back here. I don't know what the hell they were doing, grabbed the wrong wire, doesn't matter. It burned out the meter movement. The needle wasn't stuck, it's just because you can see it bounces. So it wasn't stuck. It actually burned the meter movement out, which is rare. Usually meters are just stuck, and I can get them unstuck as long as somebody else hasn't tinkered with them and stripped the screws in them. But yeah, this one, it was literally burned the meter movement out. So I had to replace the meter. See what else we got here. I got to put those back in. Once I put it's the only thing I have left to do to this is change the meter lights to LEDs. Those are the reflectors. Replace the broken clarifier control somebody had stuck in there, and of course I go to take this out, and what had they done? Drilled the hole out larger, I guess, so they could stick, and even this, the hole was way too big for this. They used a damn half-inch drill bit, a huge drill bit, to drill the hole to install this stinking pot. So of course when I go to install the correct size pot, it just wobbles around in the hole, so I had to make a bushing to go around it. So it's now in there perfect. It's in a line the way it's supposed to be, tightened up with the proper control now. So that was replaced. The DC power jack, I happened to notice that was broken out there. Here's the two ears for that. So it has a brand new 13.8 volt DC power jack, and I didn't go to bother trying to get these damn caps off, so I just installed two new ceramic caps on there. And then this is all the crap from parts from where they had done their frequency to conversion to whatever frequency. So there's everything that's been replaced. So it's now had the transceiver alignment done. It's connected to the signal generator over there, communications test set. It's on channel 19. It is in upper sideband. It is being fed a 0.05 microvolt signal, which is, get into the, I'm trying to keep this power cord out of the way, dBm. That would be minus 133 dBm. So we can go back to microvolts. Okay, so 0.05 microvolts. And what we're going to measure here is the SINAD. And it's pretty much agreed that a 12 dB SINAD is the minimum required for intelligible reception. So when basically someone's talking, you can understand what they're saying. You need at least a 12 dB SINAD. So this is being, the radio is being fed a 0.05 microvolt signal, 30% modulation with a 1 kilohertz tone. So, and then the speaker output, or the phone jack, because this doesn't have a speaker jack on the back, so you just use the phone jack. That's being run through, there's 8 ohm dummy load right here, back into the communications test set. So we're going to be measuring SINAD. So turn the volume up here. You can see it has at 0.05 microvolts, has a 17 dB SINAD. So very good SINAD reading. So excellent receiver. And if we switch to AM, get switched over here. Okay. AM. There. And what do we got here? Modulation 1 kilohertz. Oh, there we go. Modulation 30%. Okay, so it's being fed a 1 kilohertz. Same thing being get down here. So there's a 0.05 microvolt signal, 27.185 megahertz, being modulated 30%, 1 kilohertz signal. So, of course, AM reception is usually never as good, so we'll actually have to turn the level up here a little bit. And what we're looking for is 12 dB. So right there. Say 0.12 microvolts, or dBm, minus 125.4 dBm at 12 dB SINAD. So very sensitive receiver. So let me get the volume turned down so you can actually just hear what that sounds like coming out of the speaker. So there's minus 125.4 dBm in AM, which is 0.12 microvolts. So just turn that down the whole way, which is as low as the signal generator goes, 0.05 microvolts. And you can still hear it fairly clearly. And then we go to upper sideband. So there's same signal, 0.05 microvolts, 30% modulation, 1000 kilohertz, or 1 kilohertz audio. That is fantastic. Excellent reception. And that's why these Cybernet chassis and these Lafayettes are prized so much. Fantastic reception on sideband. Actually excellent on AM, but the sideband is where they really, really shine. So, yeah, that is basically a microscopic signal being fed into this radio, and it's absolutely crystal clear. So, and I hadn't even planned on it, but we'll just quick fire up the spectrum analyzer, because I know some people often ask me, I'd like to see that on the spectrum analyzer. So we're hooked up with the coax cable, runs under the bench to two 30 dB high power attenuators in series, and then into the spectrum analyzer here. So amplitude, reference offset 60 dB, frequency, start frequency, let's make that 20 megahertz, and stop is 60 megahertz. So that'll get the carrier and the 54 megahertz if there's any harmonics. So amplitude here, and auto scale. So absolutely nothing. So let's just zoom in on 54 megahertz. So we'll make the start frequency, say 53, or no, just make it, try that again. Start frequency 54 megahertz, and stop 56 megahertz. So left side of the screen's 54 megahertz, right side of the screen's, and actually I did that too far, doesn't need to go out that far, 55 megahertz, what I meant to punch in. So 1 megahertz span there. And keying the microphone, absolutely nothing there. So very good suppression on spurious emissions and harmonics. So let's just widen that back out. So start frequency 20 megahertz, and we'll make stop frequency, let's say 500 megahertz. So that will have everything. Nothing. Other than the carrier, flat. Very clean. Audio, audio, audio. And there's modulated. Let's go to sideband. Audio, 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 audio. 1, 2, 2, 2. Audio check. Absolutely nothing other than the wanted signal going out. Check sideband's carrier suppression. So we're on 19. So we'll make start frequency 27.175 megahertz and stop 27.195 megahertz. So left side of the screen's 27.175, Right side's 27.195 megahertz. So we flip to AM. You can see there's our carrier. Audio check 1, 2. Modulated carrier, and switch to sideband. So you can see here I'm talking into the microphone. There's our sideband transmission. So audio, and there's the microphone keyed. Nothing. Excellent carrier suppression on this thing. So there is a now fully restored, other than I gotta clean up the cover, wax the cover also, and then the wood end caps here. Put the 4 LEDs in for the meters, and this radio will be ready for somebody. I think the customer is going to sell this one. I think I know he has one that I've done for him already. He might have 2 in his own personal collection, so he's probably going to sell this one. So if anybody is interested in it, let me know. I can somehow I can hook you up with him. But I get the feeling he's probably going to sell this. That's what he does. He likes buying radios when he can get them cheap. Get them fixed up and selling them. That's how he's made a lot of friends that way. He's very fair on his prices too. So like I say, I think he's going to want to sell this. So if you're interested in a good working, actually excellent working Lafayette Telsat SSB-140, let me know. The only modification, after undoing all of this crap somebody had done to this, putting it back on the CB band, it does not have extra channels. That's still virgin, has never been touched. The only modification done to this radio now is the clarifier is unlocked. So it does change frequency on transmit. That is the only modification that was done to this. Otherwise, all circuitry in this radio is put back to original operating condition, the way it was designed and intended by Cybernet, and any tweaks that Lafayette might have made to it. So another Lafayette saved from the scrap heap.